all of you. So in the previous class, we were discussing about different kind of glands, their secretions, and the functions. Yes, I think we finished in thymus, or we should start from thymus. Hypothalamus we finished. Yes. What two kind of secretions of hypothalamus? Releasing hormone and inhibiting hypothalamic hormones. Pituitary gland almost 9 hormones: oxytocin, vasopressin, melanocyte stimulating hormone, growth hormone, prolactin hormone, follicular stimulating hormone, luteinizing hormone, all these things, right? And then pineal gland, melatonin, sleep-wake cycle, melatonin of pineal gland, and then thyroid and parathyroid glands. Thyroid, T3 and T4 hormones of thyroid gland, and then parathyroid gland, thyroid hormone, PTH. Okay, so I think till that we discussed. Coming to thymus gland, did we discuss about thymus gland? Thymus gland. Thymus is the primary lymphoid organ. Thymus gland is the primary lymphoid organ. Why thymus gland is called primary lymphoid organ? Because when you call an organ as primary lymphoid organ, secondary lymphoid organ, the immune cells or lymphatic system, the immune system comprises of various kind of cells. Okay, the blood cells, white blood cells, they are called what? Soldiers. White blood cells are called soldiers. They only give us immunity. Okay, and different type of immunity. One important type is humoral immunity and cell-mediated immunity. Okay, we have humoral immunity and cell-mediated immunity. Humoral immunity is because of what? B lymphocytes. Okay, humoral immunity is because of what? B lymphocytes, B cells. Cell-mediated immunity is because of what? T cells, T lymphocytes. Okay, so T cells or T lymphocytes, okay, or educators in thymus gland. Okay, T cells or T lymphocytes or educated functional maturation occurs in thymus gland. Okay, so what is the name of the hormone? Thymosin. The hormone thymosin helps in maturation of T lymphocytes. Okay, we have thymus gland, which produces an hormone called what? Thymosin. Thymosin helps in the maturation of education of, you can say, they even what is called education of T lymphocytes. Is it clear? So, very important gland. And another important aspect of this gland is it's very active in young age. Something called progressive involution. What it is? Progressive involution means when you are young, even in adult age, Your thymus gland is big, it secretes lot of enzymes and it builds hormones and it is active. And as you are aging, as we are aging, the thymus gland decreases in size slowly, slowly, slowly. The gland decreases in size. The efficiency also becomes less. So it cannot produce lot of thymoxin. Is it clear? So that is called progressive, gradual involution. So the size decreases. If size decreases, then the efficiency also decreases. So that's why in aged people, immune system gets weaker because cell-mediated immunity, the T cells are not educated by the thymus gland. Can you understand? So thymus gland plays a major role in our immune system. Okay, so education of T lymphocytes occurs there. Okay, thymus gland. The next important gland is what? Adrenal gland. Can I give the book? Okay. The next important gland is called what? Adrenal. Okay. It exists in fact on top of what? Okay. We have how many kidney? Two kidney. Okay. On top of the kidney, this adrenal gland is present. Okay. On top of both of the kidney, we have adrenal gland. Okay. Fine. So this adrenal gland, since it is present on top of the kidney, they are called what? Suprarenal gland. Okay, what's the special name given to the adrenal gland? Suprarenal gland. Okay, they are called what? Suprarenal gland, means superior. On top of the kidney, they are located. Hence, they are called what? Suprarenal gland. So, this adrenal gland consists of two important parts. Okay, so cortex, which is yellow in color, and outer side. See, the outer side of the kidney means the adrenal gland, which looks in yellow color, and that outer cortex, that region is actually called what? Cortex. Outer cortex, inner medulla. Okay, outer cortex region, which is yellow in color. Cortex region, which is yellow in color, which is present in the outside. And then medulla, second region is called what? Medulla, which is brown in color, almost brown, very strong in color, and then inner cell. Can you understand? So two regions, okay, regions of what? Adrenal gland. Outer cortex, yellow color, and then inner medulla region, which is brown in color. Okay, what we should know about that? These two regions of the north. In cortex region, three important hormones which are important. They are called what? Mineralocorticoids. Mineralocorticoids. And then glucocorticoids. Glucocorticoids and then steroids. Okay, what are the three different hormones of adrenal cortex region? Mineralocorticoids, glucocorticoids, steroid hormones, basically. So, this mineralocorticoids, minerals like sodium, and potassium. Okay, they are involved in the regulation of sodium and potassium level inside the body. Okay, mineral particles, sodium and potassium, glucocorticoids, glucose metabolism, carbohydrates basically, metabolism of carbohydrates by this glucocorticoid hormones. Okay, gluconeogenesis, especially formation and degradation, you can say. What is gluconeogenesis? Glycogenesis, glycogen synthesis, glycogenesis, glycogenesis. What is glycogen? What do you know about glycogen? Listen, in our animal body, glucose are stored in the form of what? Glycogen. In plants, glucose is stored in the form of what? Starch. In plant, glucose is stored in the form of starch. In animal cells, glucose is stored in the form of what? Glycogen. So glucose, they add it together and glycogen is formed. That process is called what? Glycogenesis. Glycogen formation process. For that, you need glucocorticoids. Can you understand? Fine. Next, steroid hormone. Basically, they are called sex hormones. Okay, androgens and estrogens. Okay, what are the sex hormones? Androgens and estrogens. Okay, androgens are male sex hormones. Estrogens are female sex hormones. Listen, actually, these hormones are primarily synthesized in androgens are synthesized in male reproductive system. Estrogens are synthesized in female reproductive system. Also, they are synthesized, they are not only synthesized in adrenal cortex region, they are actually primarily synthesized in gonads, testes and ovaries. There only these androgens and estrogens are synthesized. But also in adrenal cortex region, these hormones are synthesized. That's why we would able to find male and female sex hormones in both of the sexes. In male, you have androgens and estrogens. In female, you have androgens and estrogens. Trace amount of hormones, not in bulk, but they are present in what? Trace amount, little nano concentrations they are present. Okay, good. So these three hormones are classes of hormones are synthesized by cortex region, adrenal cortex region. Do you remember one hormone? ACTH is the pituitary hormone. One of the pituitary hormone is called what? ACTH. ACTH stands for what? Adrenocorticotropic hormone. Do you remember? Adrenocorticotropic hormone. So that hormone should come to the from pituitary to the adrenal gland, and it should stimulate the synthesis of what? All this adrenal cortex hormones. Is it clear? Right. Now, what is the special of this medulla regions of adrenal gland? Here, two hormones, two classes of hormones. Okay, something called what? Adrenaline, and then noradrenaline. Okay, what are the two hormones of this? Adrenaline and noradrenaline. Also, they are called what? Epinephrine, norepinephrine. Another name is called what? Epinephrine, norepinephrine. Adrenaline, also called epinephrine, noradrenaline, norepinephrine. Okay, so these two are the important hormones of medulla region. Okay, adrenaline, epinephrine, noradrenaline, norepinephrine. Okay, fine. So what are the functions of these hormones? Our emotions, okay, our emotions, the anger, the fear, okay, and so all these things are controlled by these hormones. Together they are actually converted. Right. Like, right. Hormones. What is called fight, like, right hormones? When the dog chases you, you run faster than the dog. Okay, normally if they ask you to run, you don't run that much faster. But when a dog chases you, you jump 6 feet wall also to escape from the dog. Exam time. Normally, if they ask you to write any assignment, in 1 hour you write 3 pages. Okay, you don't get that much of interest and you are not active. But in exam time, you write 15 pages in 1 hour. At least 10 pages in 1 hour. In 3 hours, you write more than 30 pages. Yes or no? What gives you that? That is called what? Adrenaline rush. Can you understand? So when you are so means anger, you are in anger, like you react normally. So the people will even do and murder also if the rush of adrenaline is there. Okay, so in either way, like you fight because of adrenaline, you fly because of adrenaline, you fear because of adrenaline. Yes, no, that's why these hormones together they are actually called what? Fight, flight, flight hormones. Can you understand? Exam time, you sweat. Okay, it makes you to sweat. It changes your heartbeat, increases your heartbeat. Sometimes this is good also. When you are, it makes you proactive. You're alert all the time. So it makes you to means react even more faster than your normal actions. Can you understand? So that's about these hormones. So next to pituitary, this adrenal gland synthesizes lot of hormones and they regulate lot of metabolism and functions in the body. Okay, so adrenal gland. The next gland is actually pancreas. We finish about pancreas, then it will finish. So we already saw little about pancreas. What did we see about pancreas? Is that enterocrine gland. Pancreas is actually what? It is an enterocrine gland because both exocrine secretions. What are the exocrine secretions and endocrine secretions? Okay, they are heterocrine glands. It has both exocrine secretions and endocrine secretions in our digestive system. Okay, digestive system, lot of enzymes, pancreatic amylase, pancreatic lipase. Okay, so like that, there are lot of enzymes are synthesized, which helps in digestion of substances. Right. So that secretions reaches duodenum, right, from pancreas to the duodenum, small intestine. The secretions reaches to what? Pancreatic gland. So there is a duct. Hence it is called what? Exocrine gland there. The secretions are exocrine secretions. Endocrine glands basically. So there are actually four important islets of Langerhans. Pancreas contains islets of cells. Okay? Islets of cells. In that islets, aggregation of alpha cell, beta cell, and even delta cells. Of course, gamma cells also there. Okay, but three cells are very important. The gamma cell function is not well understood, but still alpha cell, beta cell, delta cell. Okay, three types of cells are present. Cell aggregates are present in pancreas. So alpha cell secretes hormone called glucagon. Beta cell secretes insulin. Somatostatin. Delta cell produces somatostatin. What are the three important hormones of pancreas as its endocrine portion? Alpha cell produces glucagon, beta cell produces insulin, delta cell produces somatostatin. See, glucagon helps in increase of blood sugar level. Okay, insulin means glucose level in blood is increased because of the activity of glucagon. Means it creates the complex glycogen and then obviously in the blood level of glucose increases. Okay, this one insulin makes the cell to utilize glucose as its energy source, thus helps in the reduction of glucose level. Okay, insulin reduces glucose level in blood. Okay, so blood sugar level increases because of glucagon, blood sugar level decreases because of insulin. So they are what actually like calcitonin and parathyroid hormones. They are antagonistic hormones, right? One increases calcium level in blood, another one decreases calcium level in blood. And here, glucose increases sugar level in glucagon, increases glucose level in blood. Insulin decreases sugar level in blood. So they are antagonistic hormone. Can you understand? Alpha cell and beta cell. Now, somatostatin. Do you remember where we studied about somatostatin? So, this somatostatin is synthesized here. Basically, somatostatin here we have the hypothalamus. Okay, so if somatostatin is released, it makes hypothalamus or pituitary to reduce the production of one growth hormone. If somatostatin is more, production of growth hormone is less. Upon it results in what? Dwarfism. Can you understand? So no much somatostatin should be produced. Of course, it is required for controlled growth. So it regulates the growth hormone production. Hence, it is called what? Growth hormone release inhibiting hormone. Somatostatin also called what? Growth hormone release inhibiting hormone. Okay. Somatostatin also called what? Growth hormone release inhibiting hormone. Okay. Growth hormone release inhibiting hormone. Somatostatin another name. Secreted by what cell? Delta cell of pancreas. Is it clear? So this is the pancreas and their secretions. Now, testis and ovary. We go next. You want to ask anything? Okay, testis is the gonad present in male. Okay, pair of testis is present. There are two hormones, right? There are two hormones from the pituitary makes the testis to produce its what is produced in the testis. Those cells, spermatocytes, and testosterone hormone is produced. What are the hormones? Testosterone and sperm cells. Okay, what is the primary functions of these testis? Produces testosterone and then sperm cells. Okay, there are two hormones from pituitary make the testis to produce testosterone and sperm cells. Okay, so luteinizing hormone. What is called from the pituitary every 6 months. Okay, what are the two hormones of the pituitary? Luteinizing hormone and follicular stimulating hormone. The luteinizing hormone comes from pituitary to the testis. There, Leydig cells, sometimes talking about Leydig cells or interstitial cells. They stimulate the interstitial cells in the testis. When we study about the reproductive system, we will be discussing about the anatomy of the testis also. Just keep one thing in mind. The Leydig cells, interstitial cells are stimulated by luteinizing hormone, which makes the Leydig cells to produce androgens. Okay, so these androgens enter into the sperm cell, means testis enter into the a testicular lobule, something called testicular lobule. There it makes there are different cells, serotonic cells. Okay, serotonic cells, nourishing cells. They produces testosterone. Can you understand? So hormones from pituitary comes to the testis, makes the testis to produce testosterone, and thus spermatogenesis process is regulated. Can you understand? Just keep this in mind. Hormones of pituitary makes the testis to produce testosterone and then supports spermatogenesis process. Can you understand? So all primary and secondary sexual characteristics of male or depend upon what testis. Okay, what are the primary and secondary sexual characteristics? Actually, we will be discussing in next chapter. How do organisms reproduce? Okay, with all development of sex organs, production of sperm cells are primary sexual characteristics. Okay, and secondary sexual characteristics like facial hair growth, underarm hair growth, voice change, primary voice change, and the jawbone, this bone size increases. All these are actually what facial hair growth. All these are secondary sexual characteristics. They are controlled by S. Next, ovary. Okay, ovaries. How many ovaries? Ovaries. See, testis is always present outside the body. Ovaries are present inside the body. Okay, so spermatogenesis occurs in lesser temperature than body temperature. What is the body temperature? 37 degrees Celsius. Spermatogenesis can occur in 35 degrees Celsius only. So oogenesis occurs in 37 degrees Celsius. That means ovary is present inside the abdominal cavity, inside the body. Testis is present outside the body. So ovary, like the hormones connected with ovary are like estrogens and progesterone. What are they? Estrogens progesterone. Okay, two hormones, estrogen in that one class is actually progesterone. Yes, testosterone in male, progesterone in female, androgen in male, estrogen in female. Okay, keep the names in mind. Okay, fine. Again, two hormones from pituitary stimulates the ovary to produce this ovarian hormones. What are they? Follicular stimulating hormone and luteinizing hormone from pituitary makes the ovary to synthesize these hormones especially. Okay, fine. So estrogen and progesterone, ovarian hormones. And the important thing which just keep in mind, of course, about these two glands will be discussing much in reproductive system also, how to organism reproduce also. But keep in mind, in ovary, like the role of these things, like estrogen is essential for what all secondary sexual characteristics, primary and secondary sexual characteristics in female, estrogen hormone. And progesterone, actually, it is also called what? Pregnancy hormone. Progesterone, what do they call? It is called what? Pregnancy hormone. What, Harish? Hari? It is also called what? Pregnancy hormone. Because when the egg gives fertilized, listen to me carefully. When the egg gives fertilized, okay, then this like you know corpus luteum. Okay, corpus luteum. Keep this in mind. Corpus luteum. From that only egg is released. So that corpus luteum produces lot of progesterone, and these ovarian hormones are required for the uterus. Okay, they are produced in the ovary, and they are reaching the uterus basically. Implantation. What do you call the implantation? After fertilization, the zygote develops into embryo and it has to attach itself into the endometrium of the uterus. What is the inner wall of the uterus called? Endometrium. So, if this is the uterus and the inner wall is actually called endometrium. Here, if this is the fallopian from here, the egg, the fertilized egg should come and it should attach to the endometrium. Okay, so and then what forms? Placenta forms. What forms? Placenta. And then inside the placenta only, this only nourishes the developing embryo. Here the embryo, baby forms. Do you understand? So progesterone from corpus luteum of ovary supports the development of placenta, helps in the pregnancy, and then after the development of placenta, the baby nourishment starts, the baby develops. Initially, the progesterone secreted by corpus luteum, and then the placenta starts secreting progesterone. Okay, so this hormone is required till the birth of the baby. Can you understand? Hence, it is called throughout the pregnancy, this hormone is in increased level in the female body. Okay, hence this hormone is called what? Pregnancy hormone. Also called what? Pregnancy hormone. Okay, keep this in mind. Of course, we will be discussing all of the sex hormones in reproduction also. Okay, so this is about different glands and their specific functions. Okay, is it clear? So, what are the glands? Starting from head region, just list the glands of hormones if you know. What are the glands? Endocrine glands. Yeah, you tell me the endocrine glands which are present in the head region. Endocrine glands alone present in the head region of humans. Hypothalamus, pituitary, pineal gland in the head region. In the throat region, surrounding the trachea, thyroid and parathyroid. Two lobes, thyroid. In that you have 50-50 dotted parathyroid, full. parathyroid hormones. Okay, and then thymus, and then adrenal gland, suprarenal glands. Okay, adrenal glands, and then pancreas, heterocrine nature, and then testes in male, ovaries in female. So, of course, every gland is having its specific hormones. They have their specific function. Is it clear? Fine. So that's about. In the past few classes, we were discussing about nervous system, which is the physical coordination system, and chemical coordination system. The endocrine system is a chemical coordination system. Okay, all the component of nervous system, central nervous system, peripheral nervous system, autonomous nervous system, we study, and then endocrine glands, their specific hormones and their functions, we study. So this is all about what? Control and coordination system in humans. Okay, now we will start with what? Control and coordination system in plants. Okay, control and coordination system in plants. Okay, control and coordination system in plants. Just keep few things in mind. Plants do not have nerve cells, but they have hormones. Okay, we have nerve cells and hormones, but plants hormones they have, but they do not have what? Nerve cells. Okay, so there is no central nervous system. Central coordination system is actually present. Okay, internally, all the functions of the plant, the growth and development, internally controlled by what? Hormones. Externally, the growth and development, all processes are coordinated by different kind of stimulations. What are the different kind of environmental factors which regulates the growth and development of the plant, which helps in coordination, control and coordination of the plant. Like, yes, and then water, and then gravity, and then touch, physical contact of something. Okay, these factors only regulates the functions in the plants. Growth and development processes are regulated by these factors. Actually, they are called external stimulations. External stimuli or stimulations. Stimuli. Stimulations. You see, they are called what? External stimulations. How plants react to these substances. Okay, and based on that only the functions are regulated. So, one common term they use, how plant react to these factors called what? Trophism. Okay, movement of plant towards this stimulations, trophism or trophic movements. Okay, on the other hand, something called what? Nastic movement. Okay, trophic movements and nastic movements. Plant control and coordination is two kind of movements. Nastic movements, trophic movements. Based on these factors, trophic movements and nastic movements. Basically, like, there are direction oriented, directionless movements. Okay, direction oriented and directionless movement. For example, trophic movements. Plant has two systems, right? What are the two systems of the plant? Here you have what you have. Two systems in the plant. This is called what? Root system, and this is called what? Shoot system. Correct? Root system and shoot system. Okay? How they are regulated by these stipulations. Okay? First, we just take light. It is called what? Phototropism. Movement of plants towards light is called what? Phototropism. See, directed towards light. Yes or no? This is called what? Phototropism. Direction towards light. Now, both of the components of the plant, root and shoot, shows opposite direction movement. Phototropism. Root system, negative phototropism. You agree with me? Root system shows negative phototropism. In the sense what? Root grows away from the light. Yes or no? Shoot system shows positive phototropism. They move positive towards light, away from the light. So if it moves towards light, that is called what? Positive phototropism. It moves away from the light, it is called what? Negative phototropism. Can you understand? Light phototropism. Now, water. It is called what? Hydrotropism. Movement of water. Hydrotropism. Here opposite to that. Root system shows positive hydrotropism. Shoot system shows negative hydrotropism. You agree with me? Root moves towards the water. Shoot moves away from the water. So opposite directions. This is clear? That is called what? Hydrotropism. Okay. And then coming to the gravity. It is called what actually? Geotropism. Gravity means what? Geotropism. Root system shows positive geotropism. Shoot system shows negative geotropism. Can you understand? Shoot system shows what? Negative geotropism. Of course, there are little modification basically. For example, nematophores in marshland. Okay, the root also shows what? Negative geotropism. Okay, means just in if it is present in a slurry based marshland, the root cannot get nutrients or gases enough amount. So they produce this secondary root modification of the root which comes out of the land. They actually to get the gas exchange. Little in all of these things, you may have some little variations. But apart from that, in general, these are all the movements shown by the plants. Okay. That's basically you can know, nastic movement. For example, touch me not plant. Okay, what it does? If you touch, it changes its orientation. But that is not towards anything, basically. It is directionless movement. That is called what? Nastic movement. Can you understand? All these things are trophic movements. This is actually nastic movement. Okay, is it clear? Fine. Now, another important problem is basically a chemotrophism. Okay, internal factors. So all these factors are external factors. What are the internal factors which controls the processes in plants? Okay, internal factors. What are they? Okay, the internal factors, something called chemotrophism, means hormones. See, the hormones, plants are also called phytohormones. Okay, what are they called? Phytohormones, plant hormones. Okay, so movement of the plant towards or based on or function, growth and development of the plant based on the presence of hormones, different kind of hormones. They are called, that is called what? Chemotropism. Okay, chemochemical based control and coordination in plants is called what? Chemotropism. See, there are two kind of hormones produced. These hormones are actually not from the external sources. Plant themselves produces lot of hormones and regulates their functions. Okay, so these hormones are actually called what? Growth regulators. Okay, hormones are also called what? Growth regulators. What are called regulators? Regulators controls the function. Okay, even in human hormones, these are regulation, increase or decrease in both of the way. We must have a control. That is called regulation. In time, you can say regulator increases or decreases. In gas stove, you can see a regulator. Okay, to increase to decrease. Mixing grinder, you can see a regulator. In mixing, 1, 2, 3, a regulator. Okay, so control. So these regulators are again classified into two types. Growth stimulators, growth inhibitors. What are the two types of hormones produced by plants? Growth stimulators, growth inhibitors. Okay, and these hormones are basically classified into five types. First is auxins. Okay, which comes under stimulator. Auxin comes under what? Stimulator. Okay, auxin comes under stimulator. So, listen, auxin makes like root shoot development. Plant owner from shoot apical meristem, shoot develops, root apical meristem, root develops. Okay, for that growth and development of the plant is actually controlled by auxins. Okay, for example, phototropism. You know phototropism. What is phototropism? Shoot moves towards plant, right? Shoot. If this is the plant, the root is there, and then it moves towards one. The shoot is to move towards one. Like, yes or no? So the plant growth towards light is supported by what? Axis. Okay, if you keep a plant here and wherever light is available, it moves on. So axis regulates what? Movement of substances or plant towards light. That's one important function. Actually, in your book, you can see lot of other functions of axis also. Cell enlargement and elongation by axis. And then in tissue culture, say these actions are widely used in plant tissue culture function. Basically, cell order, enlargement and elongation can action support. But in laboratory, plant order, developmental. What is plant tissue culture? You know what is plant tissue culture? Little part of cambium tissues of the plant is taken, provided with the medium, and then in the lab itself, you get the plants. Callus develops, and then 50 plants develop, and that can be added to the soil, and then you get a small like plant, and then planted again, you get a lot of benefits. So that is from cultivation of the plant from cells, meristematic tissues. That is plant tissue culture. So they for the development of the plant, the classes of axons are used. Okay, axon for what? Development. Okay, first important hormone. And then gibberellins. Okay, and then it is called what? Gibberellins. This gibberellins are first actually identified from a fungus called Gibberella fungiculae. Okay, Gibberella fungiculae. From that name only these gibberellins are actually identified. So they are involved in the, again it is a stimulator, growth stimulator. Gibberellin is also a growth stimulator. It helps in what? Cell elongation, stem elongation. Okay, cell elongation more than that. So the height of the plant, because of what? Between nodes and internodes, you have some specific. So that if internode develops, plant height increases. So for that, this gibberellins are actually useful. Okay, cell division. And then the carburetive movements. So different functions are in a carried out by this gibberellins. Again, it is a growth stimulating hormone, axins and then gibberellins. And then cytokinins. In your book, actually all important functions are given ready. Keep an eye on that. So I'm just highlighting the important functions for me. So cytokinins, main function is actually cell division. Okay, cytokinin. Okay, cell division. The meristematic tissue activity is because of what is cytokinins. So listen, primary growth and secondary growth. What is called primary growth in plants and secondary growth in plants? The seed germinates, root apical meristem and shoot apical meristem. Their active cell division occurs. The plant grows. Okay, shoot development and root development occurs. For that, if active cell division occurs, then only differentiation and the development process. So for that, this cytokinins are important. Okay, so they are called what? Growth stimulating hormone. And then we have ethylene. Okay, ethylene. Ethylene has a dual property. That's why I'm just writing it here. Okay, because it makes ripening. Okay, what is ripening of the fruit? An old leaf replacement. So such kind of functions are actually done by this ethylene. Okay, ripening of the fruit, mainly part of it. And excision of what food parts. So they isolate lot of ethylene actually. So that's its important functions, ethylene. And then which also stimulates the cell for the production of what? Abscisic acid. Abscisic acid. Abscisic acid. Okay, abscisic is actually a growth inhibitor. Abscisic is a growth inhibitor which controls the growth. Okay, it depends upon the situation. Okay, so abscisic actually suppresses the growth of the plant. Growth regulation. Can you understand? So ethylene supports in the production of what? Abscisic acid. So that's why these hormones can be considered as what? Growth inhibitors. Can you understand? So main inhibitor of the growth is actually abscisic acid. So plant chemotropism means what? How the internal chemical substances regulates the functions of the growth. They are called phytohormones. The hormones of the plant control the growth and development of the plant. They are called phytohormones, and they are actually growth regulators classified into growth stimulator, growth inhibitor. Okay, absence given cytokinins support the growth and development of the plant, and ethylene, especially abscisic acid, helps in the reduction, control of the growth of the plant. So this is about the control, tropism, plastic movement, and especially the hormone-based growth means functions are the important component of control and coordination of the plant. Okay. Next, How in simple organisms like amoeba or other organisms, animals like hydra. Okay, say some organisms lowest level, like they even have only cellular level of particle system also, but they also like examples in hydra, okay, as well as in grasshopper. Okay, so hydra is what? An example of one multicellular animal. Okay, multicellular organism. Hydra is an example of what? Multicellular organisms. So in hydra, actually, they have a network. Okay, they have a network of cells. They control the coordinations. Body, all body functions are coordinated by neural network. Okay, simple organism with nervous system. They actually exist. Like that in system, they have what? Ganglia. Okay, different ganglions extended throughout the body and they can actually suffer. You know little about the cockroach. Cockroach. Cockroaches are present with the nervous system. Cockroach and it has three regions. Cockroach. What are the three regions of cockroach? Head region, thorax region, abdomen region. Three regions are there in cockroach. 10 segments. It is presented in 10 segments. In the head region, actually, they do not have well developed nervous system. Okay, but in the thorax region and the abdomen region, they have extended nerve cord with ganglia. Okay, present. The nervous system is present. So when you cut the head of the cockroach, okay, you can't remove the head of the cockroach. If all head is removed, how many days we can do? At the moment we die. But cockroach, if the head is removed, 1 week it can live. Okay, if you remove the head of the cockroach, it survives for 1 week it lives. Because the nervous system is presented, like the ganglia and the nerve part is actually presented below its head region. That's why the regulation of body functions are carried over like that. So it can live at least for a week. Is it clear? So that's about like how the nervous system works. And in your higher class, if you do you study about in all other organisms also how the nervous system is working. Here, much we are focusing on what animals as well as plants. The control and coordination system in humans and plants. Much we are focusing. The rest little information. Basically, you should know cells perform control and coordination function in simple multicellular organism network of cells and tissues themselves. Okay, like hydra or throughout the body, the nervous system is present, not just restricted to head region alone. They are also like the control and coordination can be regulated. Okay, so this is about this chapter control and coordination. So I hope like we have covered almost all of the aspect of control and coordination system. So we finished the two important chapters as of now. What are they? Life processes and then control and coordination. Okay, so go through study well, and if necessary, like maybe another class tomorrow, like we can have an open discussion on the entire control and coordination system. We have class on tomorrow or day after tomorrow, no matter. So please, I completely come fully prepared, and then if you cannot follow anything also, we can have one session for clarifying the doubts. Okay, so completely just go through and come. If you cannot follow anything, you can ask. So we can have a like a discussion session tomorrow. Okay, right. Thank you so much for your cooperation. See you tomorrow. Thank you.